Here are the last two questions on the quiz. On this side, you don't have two sets of condition. If you read it, it tells you that you've got one volume right there, you got one pressure, you got one temperature, and that's it. So that means you're going to use the PV equals nRT formula. Now I need to talk about R values. I'm going to write them up at the top. So R equals one of three numbers. It either equals 0.0821 liter atmospheres per mole Kelvin, or it equals 8.31 liter kilopascals per mole Kelvin, or it equals 62.4 liter millimeters of mercury per mole Kelvin. So they all mean the same thing. They're all equal to each other. The units are different, so therefore the numbers are different. So now you're ready to look at the equation and plug in the numbers and let's solve it. In this equation, I should maybe mention that N, that's a new variable, represents moles. All right, so in this question it says how many moles of oxygen. So you know you're trying to solve for N. So I'm going to go ahead and write an N in there. Must be placed in a 16-liter container. That's volume, 16 liters. So that goes right here, volume. So far we've addressed mole, V and N in this equation. In order to exert a pressure of 104 kilopascals, so that's over here, 104 kPas. At 25 degrees C, so it's 298. Oh, why is it 298? Because we have to add 273, just like on the other side. Now R, we got to decide which R to use. So we've got three possibilities for R. Which one would we use? Notice that the pressure's in kPas, so you have to use the 8.31 value. So it's 8.31 liter kPas per mole Kelvin. All right, so Kelvins cancel. Whoops. Right here. And on this side, nothing cancels, so we can see our units on this side are going to be liter kilopascals, and on this side, it's going to be N, some number, and our unit is going to be liter kilopascals per mole. So I'm going to pause and do the math, and then we'll see if you get what I do. What do you think you need to do next? So what I did was chose to multiply this number times this number. So when I do, I get 1664, and my unit is going to be liter kilopascals. On the other side, I've got 8.31 times 298. So I get 2,476. So now I need to get N by itself, so I divide both sides by what? You divide by the number with the variable. So liter kilopascals per mole. Everything cancels over here. I forgot to put the number in. 2476 goes there. Okay, so I get 0.67. Let's talk about units. So I'll do the units over here on the side so you can see them. I have liter kilopascals divided by liter kilopascals over moles. So I have a fraction division again. So when you divide by fractions, you multiply by the reciprocal. So you'd have liter kilopascals times moles over liter kilopascals. Notice what cancels. So my final unit is moles. Now let's take a look at the next question. 8 moles of carbon dioxide. So I'll underline what we're given. 8 moles. Placed in a container at 25 C. Are there two pressures? No. Is there or are there two volumes or two temperatures? No. So since there's none of those things, what you have to do is use this equation PV equals nRT. You only have one set of conditions, so use the ideal gas law. All right, so this time we'll look at our variables and see if we can find anything to match them. So I got a P right here. So pressure, 800 millimeters of mercury. All right, we're looking for volume. So for volume, we just put a V in. 8 moles, that'd be N. R. All right, the unit is in millimeters of mercury. The unit of pressure, I mean, is millimeters of mercury. So if you remember these R values, the one that matches is, is this one, 62.4. So I'll put in 62.4 liter. I'm just going to go liter torr per mole Kelvin. Now, torr is the same as millimeter of mercury. Just trying to remind you of that. The temperature had to be 298. It says 25. Why am I changing it to 298? Add 273. All right, so I'm going to work out some numbers. So I'm going to do some math. What am I doing? See if you can figure out the answer that I'm going to write down. Use the calculator. All right, you got a pretty big number, 148,762. Units, notice how moles are gone. Kelvin's gone, that's supposed to be Kelvin there, they're canceled. So all I have left is liter torrs. Okay, on this side I got 800, do I have a variable? I don't, it was on this side. On this side, I got 800 millimeters of mercury. Do you guys remember that millimeters of mercury and torr are the same thing? So I just put 800 torr. So now we're going to need to simplify this equation by getting the V on a side by itself. To do that, I need to get rid of the number that's with the V. So what do I divide both sides by? All right, you divide by the number with the V. So it's 800 torr. Oh, look, torrs cancel. That's convenient. So we're going to be left with liters. So let's figure out how many liters. I get 186. So it's a 186 liter container. And that would be the end of that problem. If you want to try doing the bonus, you know that you had 8 moles of carbon dioxide. Moles go on the bottom, grams on the top. 1 goes in moles. 12 plus 16 times 2 gives us 44 grams per mole. So our final answer would be 352 grams. And that would have gotten you 2 bonus points. So there you have it, the quiz.